Okay, hi guys, welcome to this lesson. This is based on Text and Test 6, chapter 3.7, page 120. We're going to do these questions here. The topic is polar form. Now, if you haven't already, I might ask you to go and first watch a video called Text and Test 6, chapter 3.7 extra, which should be beside this one, just on the unit circle and finding sine, cos, and tan for angles that are bigger than 90 degrees. So polar form is the idea that there's more than one way to locate where you are on a coordinate diagram. One way is to say, well, I've gone across 3 and I'm going up 3, so that's where I land. So there's Z1, 3 plus 3i. Anything that gets you to that position is a valid way of expressing that number. So another way is to say, well, how far am I from the origin? That is, what's the modulus here? And hopefully we're happy enough that that's going to be 3 squared plus 3 squared root 18, which is about 4.2. Okay, so it's about 4.2. So what we say is, well, I'm 4.2 along on my x-axis. And if I rotate through the correct angle, I'm going to land up here. Okay, so rather than talking about how far across and up we're going, what we're now talking about is how far am I from the origin and what angle have I rotated through. So in this case, we are root 18 from the origin, and the angle you've rotated through is, well, you can find that angle by saying there's the opposite and there's the adjacent. So that's tan inverse of y over x, which is tan inverse 3 over 3. So that angle is 45 degrees. So another way of saying it is, well, I'm 4.2 from the origin and I've rotated from the positive sense of the x-axis, is what we call this. I've rotated through 45 degrees. So how do we express that then, I suppose, in polar form? Well, polar form of any number is going to be z is equal to the modulus of z times cos of what's called the argument. So our argument is 45 plus I sine of the argument. So for our number here, that's going to be, the modulus is root 18 cos 45 plus I sine 45. And you can take that back. That's polar form. That's this number up here, just in a different form. Now in terms of how far am I from the origin and how much have I rotated. You can show that that's just going to go back to this by just going to your calculator and say, well, root 18 times what? Cos 45 is 1 over root 2. Sine 45 is also 1 over root 2. Your calculator might give you root 2 over 2, which is the same as 1 over root 2. If you just multiply top and bottom here by root 2, you get this. So your calculator won't give you an irrational denominator. So that's going to be root 18 over root 2 plus I times root 18 over root 2. And that's going to be root 9 plus root 9i, or 3 plus 3i. So it's the same number. Okay, what about if we go into the next quadrant? So minus 3 plus 3i. Hopefully we're happy enough that, again, when you do Pythagoras, you're going to find that root 18 is your modulus. This time the angle you've rotated through, so it's up around here again, around 4.2. It's just the angle you've rotated through is this angle here. It's much bigger. And these aren't lining up perfectly at 4.2 just because I haven't drawn a very accurate, my x and y axis, my imaginary and real axes aren't on the same scale. So sorry about that. But that angle there is what we're interested in this time. That's our argument. Now the argument you can find if you know this angle here. So this angle is called our reference angle. And that again is tan inverse opposite 3 over adjacent 3. So our reference angle here is 45 degrees. Okay, but our argument now, how far we've come from the positive sense of the x-axis, is 180 minus 45 degrees. Okay, so that's 135 degrees. So this number here, Z2, which is minus 3 plus 3i, in polar form, Z2 is going to be the modulus, root 18, times cos 135 plus I sine 135. Okay, and again, if you go and do the calculator work on that, that's root 18 times minus 1 over root 2. Okay, that's negative, which if you watch this video up here, you'll know that cos can now have negative values, as can sine, plus I times 1 over root 2. This one, sine of 135, is positive. So that's going to be minus root 18 over root 2 plus I times root 18 over root 2. So that's going to be minus root 9 plus root 9i, or minus 3 plus 3i. So it's the same number, okay? So this is writing it in polar form. So let's have a look, just question 1, part 1. I'm only going to do part 1 of question 1. Asks you, express each of the following in the form a plus bi. So that's called rectangular form. So here, minus 3 plus 3i is rectangular form. So express this in rectangular form. Now, they use pi in this exercise. I'm not going to discuss why today, but for the moment, we'll say pi just equals 180 degrees. So we want to say, well, what's 4 cos pi over 2 plus I sine pi over 2 in rectangular form? So convert from polar to rectangular, bearing in mind that, I'll just put it up here, pi is 180 degrees. Anytime you see that, just say it's 180. So that's going to be 4 cos 180 over 2 plus I sine 180 over 2. Okay, which is 4 cos 90 plus I sine 90. And go to your calculator. You get 4 times the cos of 90 degrees is 0, plus I, the sine of 90 degrees, is 1. So we get 4i is that number in rectangular form, or if you prefer, maybe 0 plus 4i, just so that you've got your A and B that they've asked for. Question 3 is, actually I've got this already done here. Question 3 is asking you to go the other way. It gives you the number. It says write it in polar form. Okay, so to get it in polar form, you need to know the distance and you need to know the argument. Well, the distance is the modulus. So modulus here is square root of 1 squared plus 1 squared. So that's root 2. The argument, well, here's our reference angle, but in this case it's the same as the argument, and that's going to be tan inverse 1 over 1. So that's 45 degrees. So to write this in polar form, it's going to be root 2 times cos of 45 plus I sine 45. This one down here, same idea. You need the modulus. So the modulus here of minus 2 plus root 2i is the square root of 2 squared, like minus 2, it doesn't matter, minus 2 or 2 squared, plus root 2 squared. That's going to be root 4 plus 2. Root 6 is our modulus. Now the argument, well, here is our reference angle. tan inverse, that's root 2i, it's about 1.4, and 2 is the distance along the bottom. So root 2 over 2. Don't be tempted to take the negative numbers here, just take whatever the positives are when you're finding the reference angle. And the inverse tan of root 2 over 2, I think this is, well, let's have a look. Inverse tan, root 2 over 2. Oh, it's about 35 degrees. Okay, that's a bit of an awkward one. 35.26 degrees. What we'll get here then is an argument. So the argument, remember, is this angle here, which is 180 minus the reference angle. Okay, so the argument is going to be 180 degrees minus what we just found, the inverse tan of root 2 over 2, which is going to be 180 minus this, 144.7. And our number in polar form is going to be root 6 cos 144.7 plus I sine 144.7. Now I feel kind of weird about this, so I'm just going to double check that. There's my answer. But if I just do root 6 cos 144.7, I should get minus 2. So let's see if that's what I get. Root 6 cos of that answer minus 2. Yeah, okay. And then I should get a square root of 2, which is about 1.4 when I do root 6 times the sine of 144.7. And I get something around 1.4. Okay, so I've got that right. Just the numbers come out funny. That's part 3. Part 6 here, minus 5. Sorry, I'm sure I meant to do part 7. So I'm going to do part 7. It's minus 3i. Express it in polar form. So if z equals minus 3i, well, the modulus of that number, how far am I from the origin? The answer is 3. And the argument of z is this angle here. Okay, so I'm at 3 and I've had to rotate around this much. So that's a 270 degree rotation. So I can just read that off the diagram. It's 270. So just to finish that down here, z in polar form is going to be 3 cos 270 plus I sine 270. And lastly, we're going to have a look at question 8. Question 8 says, let z2 be t plus 8i, where t is a real number and I squared is minus 1. Given that the argument of z2 is 3 pi over 4, find the value of t. Okay, well, the argument of z2 is 3 pi over 4. That's 3 over 4 times 180. That comes out as 135 degrees. So if you try and draw that onto an Argand diagram, there's 8i marked there. 135 degrees is around here somewhere. So there's our number, whatever it may be. Okay, t is whatever this coordinate is down here. If that's 135 degrees, my reference angle here is 45 degrees, which makes this an isosceles triangle. Okay, so if that's 45, that's a right angle. If it's got 8 here, it has to have 8 there. Okay, but that of course is on the negative side of the number line, so t has to be minus 8 is your answer, to give an argument of 135. Okay, in class tomorrow, please, can you work on page 120, 121? We're going to do questions 1 to 4. See you then. Thank you.